Hi everyone, this is the first part of my two-part sequence introducing the supply and demand model. I decided to record the first half of this chapter so that we can focus on applications of supply and demand during the face-to-face meeting. I encourage you to email me or talk to me before or after class if you have any questions on this material. Consumer behavior is depicted by demand, which is the relationship between the price of a product and how much consumers are willing and able to buy at that price, which is also called quantity demanded. Price and quantity demanded are inversely related. In other words, when a product becomes more expensive, quantity demanded will decrease since consumers don't like paying higher prices for a particular product. Therefore, price and quantity demanded are negatively correlated. On the other hand, quantity demanded increases when a product becomes cheaper. So a product going on sale should induce more consumers to buy it. We can illustrate the inverse relationship between price and quantity demanded using a downward sloping demand curve. In this two-dimensional graph, price is on the y-axis and quantity demanded is on the x-axis. Throughout this course, we will use P to denote price and Q to denote quantity, so you'll notice that the vertical axis is labeled using P while the horizontal axis is labeled with a Q. Notice that we focus on quadrant 1 because we assume that both price and quantity take on positive values. A negative price technically means that the company is paying its customers to acquire its product, which doesn't make sense. Neither does the idea that consumers want to buy a negative amount of product. The demand curve is not permanent. Instead, it can change by either shifting to the right, such as going from D1 to D2, or the demand curve can shift to the left, such as going from D2 to D1. The demand curve shifts to the right whenever demand increases, meaning that consumers value the product more such that there is an increased quantity demanded for each and every price point. On the other hand, the demand curve shifts to the left whenever demand decreases such that each and every price point is associated with lower quantity demanded. The next slide lists the factors that can shift the demand curve. The first demand shifter is taste and preferences, which is another way of saying popularity. When products become more popular for whatever reason, that would lead to an increase in the demand curve. So if eating an apple every day makes you less likely to get sick, then the demand for apples will shift to the right. When products become less popular, the demand curve will shift to the left. We have to be careful when we consider income as a demand shifter because an increase in income can cause either an increase or decrease in demand, depending on the product. Let's suppose that you get a $1,000 bonus at work. What would you spend that money on? If you're like me, you might buy more clothes, book a vacation, or go out to a fancy restaurant. Hopefully you can do all three. Notice that this increase in your income leads to an increase in your consumption of clothes, hotels, and restaurant meals. As such, the demand curves for clothes, hotels, and restaurant meals would shift to the right. We refer to these products that you buy more of when you are wealthier as normal goods. Well, we don't necessarily buy more of everything whenever we get a raise. Indeed, you might actually buy less of some products now that you got a bonus. When I accepted Loyola's job offer, I made a promise to myself never to buy instant ramen noodles ever again. In other words, my increase in income led to a dramatic decrease in my demand for instant ramen noodles. We refer to these products that you buy less of when you are wealthier as inferior goods. Other examples of inferior goods include private label brands of food and household products. So the next demand shifter is the price of related goods. Just like with income, we have to be careful to distinguish between two different types of products when we're thinking about the relationship between two different products. Substitutes are two products that essentially serve the same purpose. Examples of substitutes include different beverages like coffee versus soda, or different brands like Starbucks versus Dunkin'. If we consider the demand curve for Starbucks coffee, then the demand for Starbucks would increase if Dunkin' increased its prices. We learned earlier that a higher price leads to lower quantity demanded, so Dunkin's price hike would cause some customers to switch to Starbucks instead. However, if Dunkin' lowered its price, then they would steal some of Starbucks customers, so a lower price for a substitute would shift the demand curve for Starbucks to the left. Not all products are considered substitutes. There are certain products that are bought in conjunction with one another, like peanut butter and jelly, so we refer to those products as complements. When the price of peanut butter increases, then you would buy less peanut butter, and so you would also buy less jelly. Therefore, the demand curve for jelly shifts to the left due to an increase in the price of a complement, like peanut butter. The opposite is also true in the sense that the demand curve for jelly would increase if peanut butter got cheaper. Consumer behavior is also affected by expectations of future prices. Recently, my sister was looking to get a new iPhone. There's nothing wrong with her phone, but she just wanted an upgrade. I told her if she wants to get the best deal, then she should wait until September when the next iPhone will come out, and then the current generation will become cheaper. Her expectation that the future price of the current version of the iPhone will go down led her to hold off on her purchase. In other words, when consumers anticipate lower prices in the future, then the demand for that product decreases today. Certainly, a lot of other consumers have the same expectation, so the demand for iPhones shifts to the left in the summer in anticipation of a better deal when the next version comes out in the fall. The last demand shifter is the number of consumers, which is another way of saying market size. Let's suppose you work at Uber and you're thinking about the demand for Uber in New York City versus Baltimore. The demand for Uber will be larger in New York City than in Baltimore just by the mere fact that New York City has a larger population than Baltimore. So the demand for Uber in New York City is to the right of the demand for Uber in Baltimore. The previous slide referred to changes in demand, which is another way of saying a shift in the demand curve. We just went through a list of 5 demand shifters, so what do I mean here by a change in quantity demanded? Notice that a change in the current price of the product was not included as a demand shifter in the previous slide. If a manager at Safeway decides to put strawberries on sale today, then the demand curve for strawberries does not shift. Instead, we have movement down the demand curve. Recall the graph from slide 3. A sale would be represented as a decrease in price from P1 to P2, which leads to an increase in the quantity demanded from Q1 to Q2. Notice that this is illustrated as movement from point A to point B along the demand curve. Economists are very picky about terminology. Note that an increase in demand means that there's a shift in the demand curve to the right, whereas an increase in quantity demanded means that there's movement down the demand curve. An increase in demand for strawberries can be caused by strawberries becoming more popular, consumer incomes increasing, assuming strawberries are a normal good, the price for blueberries, a substitute, increasing, the price for whipped cream, a complement, decreasing, the expectations of higher prices for strawberries in the future, or an expansion of strawberry exports to Canada. However, if the only thing happening to the strawberry market is that the price of strawberries is lower today, then that is associated with an increase in quantity demanded. It is really important to fully understand this distinction and to use the right terminology when discussing demand in class and in your assignments. Let's wrap up this video by taking more of a mathematical approach to studying demand. We previously illustrated the demand curve as a downward sloping line to account for the inverse relationship between price and quantity demanded. Now we want to consider the functional form of that line. So typically you have the dependent variable on the y-axis and the independent variable on the x-axis. Recall that the graph for the demand curve has price along the vertical axis and quantity demanded along the horizontal axis. One thing that's weird about economics from a mathematical perspective is that in the real world, consumers are actually given the price of a product and use that information to determine how much of that product to buy. When I go to Safeway to buy apples, I can't just bag a bunch of apples and go to the register and say I'm paying 50 cents for a pound of apples. That would be ridiculous. Instead, Safeway will post the price of apples and I can figure out how many apples I want to buy. This means that in the real world, the independent variable should be the price and the dependent variable should be the quantity demanded. So mathematically, we should think about this as quantity on the y-axis and price on the x-axis because, again, we as consumers take the prices given and use that to determine how much we are willing and able to buy. But the way we graph this type of consumer behavior is the opposite, or the inverse. So what we have at the top of this slide is called the demand function. quantity demanded is equal to 15 minus 2 times the price. That's our equation for the demand function. If we plug in the price for apples into P, then this equation spits out how many pounds of apples to buy, which is QD. Notice the negative sign in front of price, which infers that the higher the price, the lower the quantity demanded. However, this is not the equation we use to graph the demand curve. Instead, we have to take the inverse of the demand function by isolating price on one side of the equal sign. We can move 2p to the left-hand side of the equal sign and qd to the right-hand side of the equal sign to get 2p is equal to 15 minus qd. And so to isolate p, we divide both sides by 2 to get that p is equal to 15 divided by 2 minus 1 divided by 2 qd, or p is equal to 7.5 minus 0.5 qd. Therefore, the y-intercept for the demand curve is 7.5 and the slope of the demand curve is negative 0.5. This negative slope is the reason why the demand curve is downward sloping. We'll come back to this equation when we meet for the face-to-face session on the second half of this chapter. This video covered the consumer's decision-making process. We will switch to the firm's perspective in the next video, in which I'll cover the supply curve. Feel free to email me with any questions that you have.